Peace be unto you and your family. 12th Chemistry, Refresher Course Model, Unit 2, Balancing the Chemical Equation. What is meant by a chemical equation? A chemical equation represents an actual chemical change in terms of the symbols and the formula of the reactant and product. For example, A plus B gives a C plus D. In this equation, A and B are called reactants and C and D are called the product. AB reactant, CD product. The arrow mark shows the direction of chemical reaction. That means all the reactants are completely converted into product. There are many types of chemical reaction. One of these reaction is oxidation reduction reaction. What is oxidation reduction reaction? It is also called redox reaction. Both reduction and oxidation takes place. All oxidation reactions are accompanied by reduction reactions and vice versa. So, if oxidation takes place, if one compound undergo oxidation, another compound undergo reduction. Such reactions are called redox reactions. What is meant by oxidation? Addition of oxygen, electronegative element to a substance, or removal of hydrogen, removal of electropositive element from a substance, the reaction involving loss of electron, that means electronic concept, a reagent which can increase the oxidation number of the element is called oxidizing agent. What is meant by reduction? Opposite to oxidation. Addition of hydrogen, addition of electropositive element to a substance, or removal of oxygen or removal of electronegative element from a substance, that means electronic concept. The reaction involving gain of electron is called reduction. A reagent which lowers the oxidation number of an element is called as reductance, that means reducing agent. Oxidation number. Oxidation number is defined as the imaginary charge left on the atom when all other atoms of the compound have been removed in their usual oxidation state that are assigned according to set of rule. Rule number 1, the oxidation state of free element is 0. Sodium, gold, silver, platinum, if it is present in free state, its oxidation number 0, and also the oxidation number of homogeneous diatomic molecule is also 0. Rule number 2, for ion containing single atom, oxidation number is equal to charge on the ion. Rule number 3, algebraic sum of oxidation state of all the atoms in a molecule is equal to 0. While in ions, it is equal to the net charge on the ion. For example, now we are going to calculate the oxidation number of phosphorus in orthophosphoric acid. It consists of 3 hydrogen atoms and 1 phosphorus atom and 4 oxygen atom. We know the sum of the oxidation number of the element in a molecule is equal to 0. 3 into hydrogen oxidation state plus 1 plus we have to find out the oxidation number of phosphorus, put it as X plus 4 into oxygen oxidation state minus 2 equal to 0. 3 into plus 1 equal to 3 plus X, 4 into minus 2 are 8 equal to 0. X minus 8 plus 3 equal to minus 5 equal to 0. X equal to plus 5. Oxidation state of phosphorus in orthophosphoric acid is plus 5. When we write the oxidation number, we have to write along with this sign. Plus indicate loss of electron, minus indicate gain of electron. Now, we are going to find out the oxidation number of chlorine in Cl2O3. 2 chlorine atoms and 3 oxygen atoms are present, total equal to 0. 2 into chlorine oxidation state minus 1 plus 3 into oxygen oxidation state minus 2 equal to 0. Now we have to find out the oxidation number of chlorine, therefore put it as X. 2 into X equal to 2X, 3 into minus 2 equal to minus 6 equal to 0. 2X bring the minus 6 to the right hand side, it becomes plus 6. X equal to 6 by 2 equal to plus 3 is the oxidation state of chlorine in Cl2O3. Come to the next heading, balancing the redox reaction using oxidation number method. In this method, the number of electrons lost or gained in the reaction is calculated from the oxidation number of element before and after the reaction. This method is illustrated in the following example. Dichromate ion plus sulfite 2 minus ion gives chromium 3 plus ion and SO4 2 minus ion. Now, we have to find out the oxidation number of chromium and sulfur separately. In Cr2O7 2 minus, the charge is 2 minus, that should be on the right side minus 2. One oxygen oxidation state minus 2, 7 oxygen minus 14. So, by putting plus 2, plus 12 for chromium, we will get minus 2. 2 chromium plus 12, 1 chromium oxidation state plus 6. Therefore, the oxidation state of chromium in dichromate ion is plus 6. Come to sulfite 2 minus ion. Sulfur SO3 2 minus ion. So, that charge is equal to minus 2. 1 oxygen minus 2, 3 oxygen minus 6. By putting plus 4 to sulfur, we will get minus 2. The sulfur oxidation state in sulfite is plus 4. Come to right hand side, chromium plus 3. Sulfate ion, SO4 2 minus ion. SO4 minus 2, that is equal to minus 2. 1 oxygen minus 2, 3 oxygen minus 18. By putting plus 6 in, the oxidation state of sulfur is plus 6. We will get minus 2. Oxidation state of sulfur is plus 6. When we move from left to right, the oxidation number of chromium plus 6 to plus 3, oxidation number decreases. Therefore, it is called reduction. How many electrons are involved? 3 electrons are involved. When we move from left to right, the oxidation number of sulfur increases. Therefore, this is called oxidation, in which how many electrons are involved? 2 electrons are involved. So, in chromium, how many electrons are involved? 3 electrons are involved here. Here 2 electrons are involved. The next step, we have to cross multiple the number of electron. 2 by here, 3 here. Here, right hand side only 1 chromium is present. Already it containing 2 chromium. Therefore, there is no need to multiple the chromium by 2. It also containing 2. So, the equation is Cr2O7 2 minus ion plus SO3 2 minus ion gives Cr3 plus ion and SO4 2 minus ion. SO4 2 minus ion. When we cross this by 3, already it containing 2 chromium, 2 chromium, 2 chromium. Now, except oxygen and hydrogen, we have to balance the other element. 2 chromium, 3 sulfur, 3 sulfur. Now, we have to balance the oxygen atom. 3 into 3 are 9. 9 plus 7 equal to 16 oxygen on the right hand side. Here we have 12 oxygen. So, remaining 4 oxygen is balanced by adding water molecule, 4 water molecule. Hydrogen, 4 into 2 are 8. Hydrogens are balanced by adding H plus ion in the opposite side. Equation is balanced. Come to the next equation. Come to the second balance equation. MnO2 plus HCl gives MnCl2, Cl2 plus H2O. 1 oxygen minus 2, 2 oxygen minus 4. Therefore, manganese oxidation state plus 4. 1 H plus 1, 1 chlorine minus 1, 1 chlorine minus 1, 2 chlorine minus 2. Therefore, the oxidation state of manganese plus 2. Homogeneous diatomic molecule oxidation state 0. When you move from left to right, the manganese oxidation state decreases. If the oxidation number decreases, it is called reduction. How many electrons are involved? 2 electrons are involved. 4 minus 2 equal to 2. Chlorine oxidation state increases from minus 1 to 0. Oxidation number increases. This is called oxidation. 1 electron is involved in this. So, how many electron? Manganese 4 plus 2. 2 plus 2 electrons are involved. Here 1 electrons are involved. We have to cross multiple these two molecules by number of electron, here number of electron. So after multiplication, now I write the equation. 1 manganese, 2 oxygen, 2 oxygen. Chlorine, 2 plus 2 equal to 4 chlorine, therefore here 4 chlorine. 4 hydrogen, equation is balanced. Come to the third equation, balancing the equation by oxidation number method. Potassium permanganate oxidizes sodium sulfide into sulfate. In sodium sulfate, in potassium permanganate, manganese plus 7 oxidation state, sulfide plus 4 oxidation state, manganese here plus 4, sulfate plus 6 oxidation state. When you move from left to right, the oxidation number of manganese decreases from plus 7 to plus 4. Number decreases, therefore it is called reduction. How many electrons are involved? 3 electrons are involved. Sulfur oxidation state increases from plus 3 to plus 6. Number increases, therefore it is called oxidation. How many electrons are involved? 2 electrons. We have excess 1 hydrogen here. So how many electrons are involved in the reduction? 3 electrons. How many electrons are involved in the oxidation? 2 electrons. First we have to multiply these two molecules by 2 and by 3. After multiplication, now I write the equation. So potassium permanganate is multiplied by 2, sodium sulfate is multiplied by 3. Now we have to balance the other element. 2 potassium, 2 manganese, 3 into 2 are 6 sodium, 3 sulfur, 3 sulfur. Now balance oxygen atom. Here 3 into 3 are 9 plus 8 equal to 17 oxygen on the left hand side. Here also 3 into 4 are 12 plus 4 equal to 16 plus 2 equal to 18. Here 17, there 18, therefore one oxygen is balanced by adding 1 water molecule. By adding 1 water molecule, hydrogen is also balanced. This is the balanced equation. Come to the next heading, stoichiometry. Stoichiometry is a quantitative relationship between reactant and product in a balanced chemical equation in mole. The quantity of reactant and product can be expressed in terms of moles or mass unit or volume. This is mass, number of moles and volume at 0 degree Celsius and 1 atm pressure. Number of moles is divided by molar mass gives mass. We know number of moles equal to mass by molar mass. So number of moles if divided by molar mass will give mass. Number of moles is multiplied by end molar mass will gives mass. How to calculate molar mass? Bring the molar mass to the right hand side. Molar mass equal to mass by number of moles. Like that here. Number of moles is multiplied by 22.4 liter will give volume. Number of volume is divided by 22.4 liter will give the number of moles. Come to the next one, very most important. What is meant by limiting reagent? When one of the two reactants is present in less than the stoichiometric amount required by other reactant, that reactant is known as limiting reagent. In other reagent which are in excess are called the excess reagent. For example, 646 gram of ammonia is allowed to react with 1.144 kilogram of carbon dioxide to form urea. NH3 plus CO2 gives urea plus H2O. The question asked is, calculate the quantity of urea formed in gram, which is the limiting reagent. Now, the balanced equation, right hand side 2 nitrogen, therefore 2 ammonia plus carbon dioxide gives urea plus water molecule. Reactants, we know 2:1 ratio, 2 ammonia undergo reaction with 1 molecule of carbon dioxide gives the product 1 molecule of urea and water molecule. First we have to calculate number of moles of reactant allowed to react. Number of moles formula mass by molar mass. Mass is given in our problem 446 divided by molar mass of ammonia equal to 17. Nitrogen 14, 3 hydrogen 3, 14 plus 3 equal to 17. When you cancel, you will get 38 moles. Carbon dioxide is given in kilogram, 1.144 kilogram. When we convert the kilogram into gram by multiplying with 100144 divided by 44. 44 is the molar mass of carbon dioxide, carbon 12, 2 oxygen 32, 44. When we cancel, we will get 26. Now, from the ammonia, 2 moles of ammonia means 38 moles. 1 mole of ammonia means 19 mole. So, here wherever 1, it is 19 mole, 2 means 38. 1 mole equal to 90 means here actual number of moles consumed during the reaction rate, 1 mole equal to 19, product formed 1 mole equal to 19, 1 mole equal to 19, 2 moles equal to 38. Number of moles of reactant left at the end of the reaction, 38 moles we started, 38 moles undergo reaction, 38 minus 38 equal to 0. 26 moles minus 19 moles will give 7 moles. This is excess reagent, this is limiting reagent. Number of moles of urea formed 19, number of moles of water molecule formed also 19. The question asked is quantity of urea formed. The amount of urea formed equal to number of moles of urea formed 19 into molar mass of urea. Urea molecular formula we know NH2CO NH2. It consists of 2 nitrogen, 2 into 14 atomic mass divided by 1 carbon, 1 into 12, 1 oxygen, 1 into 16, 4 hydrogen, 4 into 1. When we add all this, we will get 60. 60 is the molar mass of urea. 60 into 19 gives 1140 gram. That is equal to 1.14 kilogram. Excess reagent left over at the end of the reaction is carbon dioxide. 7 moles are left over. The entire quantity of ammonia is consumed in the reaction. So, ammonia is a limiting reagent. Some quantity of carbon dioxide remains unreacted. 19 moles. So, carbon dioxide is excess reagent, 7 moles, 7 moles, not 19 moles, 7 moles, it is the excess reagent. So, this is our second discussion. Now, we discussed in this as balancing the chemical equation, oxidation reduction, redox reaction, oxidation number, then stoichiometric limiting reagent, how to balance the equation by oxidation number, all we discussed. Thank you for watching. If you like, please subscribe. Thank you very much.